Good morning from Los Angeles. My name is Saker Clipston. I want to welcome everybody to the TPC today. And I want to give a big thanks to everyone working at the TPC for having me here. And if you're interested in the Pipeline Conference, just go to thepipelineconference.com to find out more information on how you can contribute. So today we're going to have some awesome guest speakers. It's the first of a two-day series, and we're covering the topics around containers and orchestration pipelines for VFX and animation. Specifically today, we're going to be meeting with Alex Hatfield, the CEO of Juno FX, and Alex Des Katiner, and he's the lead developer of engineering to talk about how they've used Kubernetes and Pulumi to build, a pretty simple yet powerful platform, allowing you to spin up infrastructure around the world pretty rapidly. Just some housekeeping. This coming Thursday, the second part, Thursday, November 14th at 1 p.m. Pacific, we'll be covering more of the orchestration aspect with the folks at Netflix and Effectual. So please, if you haven't registered for that, please sign up for that. And then just some housekeeping. We're going to be recording this, and it'll be posted up on the YouTube's TPC channel in the upcoming weeks. And then early next year, we have some topics around AI and machine learning for VFX and animation and game studio pipelines. So that hasn't been announced yet, the dates, but keep an eye out on that. And then also down at the bottom, there's a QA button. Please put your questions in there, and we're going to be fielding all those questions, and hopefully we'll have a lot of time to have a discussion and kind of talk about some of those questions and topics. And then also, if you can, please, I know you guys have been sharing already, but please share in the chat where you're viewing from, what company you work for, or school, or anything like that, how large your team is, and then more importantly, what topics you guys might want to see in the future. We're always trying to gather information for the TPC to figure out what's next. So all this information really helps about who our audience is and what we can do to better that. So with that, I will let Alex get started. Welcome, Alex.
Yeah, thanks, Saker. So yeah, I'm going to go ahead and start with presenting some of the things that we have prepared for the presentation. I'm going to go ahead and share this screen. So I'll assume everybody can see it. So yeah, we're Juno. We're actually two different companies, Juno Innovations and Juno FX. We'll kind of go into that here in a little bit. But thank you all so much for coming and being interested in what we're going to talk about. And I feel like I should probably introduce myself. So it's kind of weird just having this guy that's kind of just nobody's ever really seen before talk about this stuff. So my name's Alex Hatfield. I've been in visual effects for about 15 years. Some interesting things about me. I actually started my career as a gaffer on set. So I started after high school and actually started working out in LA. And then I started working on bigger projects in visual effects because I got my start at Digital Domain in Florida. I was a stereoscopic compositor, and then I was actually a regular compositor. Then I started doing technical direction and doing nuke tools as well. And then I went up to Blue Sky, and I traveled all over the place and did kind of the New England tour. And then I also worked in automotive for a little bit as well, working with big data and converting all that information and creating a nuke pipeline to do like build your own on the website where you could create your own little car and you could order it like that. And that was all done in Nuke, also in Maya, and we would take all the AutoCAD data and load it in. But me personally, I was originally born and raised in Florida, and I hate the cold. So all of the jobs I was getting were up north. And so what I wanted to do is my dream was I wanted to be able to work on these really great projects, but still be in the warmth and not freeze. So we actually started creating Juno. And that was just kind of the idea was I wanted to be able to work from home and not go all these other places. And so the other thing too is I wanted to kind of share our goals and how we go to solve a lot of these challenges. For example, we're going to talk about Pulumi. We're going to talk about how we use GitOps, how we use Kubernetes, how we use containerization. and kind of how Juno is a little different than I think most other studios out there, and how we're actually kind of what we feel like leading the pack when it comes to using a lot of these newer technologies. And some other thing as well is that I actually, when I'm down here in Florida, I usually wakeboard. My knee's a little messed up right now. But I actually go out and I wakeboard, and the whole idea was, like I said, I want to be able to live down here, work on these really cool projects, go wakeboarding, and not freeze. So that's a little bit about me. The next person we want to talk about is actually Alex. And so Alex is our lead DevOps engineer. He's actually been on the team for about a year now. He takes care of a lot of our containerization stuff. A nice thing that I think he might allude to here in a second, I'll have him introduce himself. He didn't know any of this stuff when he first started. So he came in as a technical director, and he's learned a lot of these new technologies, which, it kind of shows that it's not really a super scary thing to get into, and it's not really that hard. But I'll let him introduce himself.
Hi, everybody. I'm Alex Des. I started as an artist, worked from television across advertising, gamification to VFX. Last position was a technical director pipeline, and I'm Juno Innovations now, together with Alex. And yeah, I didn't do any Kubernetes stuff beforehand, and that's about it.
Yep. Yeah. So, yeah, that's kind of some interesting thing about Juno, is that we're only about 4 or 5 developers, but we actually support a studio that goes out and does work, which I'll talk about here in a minute. But I want to go ahead and start talking a little bit about the topic, right? So a lot of people are mentioning this nowadays. Like, how do we modernize visual effects? How do we go about, like, what does that actually mean? What does it mean to do modern visual effects, right? So about 3 years ago now, Juno's about 3 years old. We kind of posed that question to ourselves, right? So how can we work from anywhere in the world? How can we actually scale up when we need it? How can we scale down? And so we found that a lot of these questions, visual effects as an industry kind of ask themselves, but they don't really look to other industries very much. They kind of just try to recreate their own solution for it. Because that's kind of what we are, right? We're builders, we're creators. And that's just kind of in our nature to do that. For us, we were such a small team that we needed to look out. And at the time, we didn't have any relationships with larger companies. So we wanted to look to other industries to see how do they handle these things. So the question really is, what happens when you merge the best DevOps and GitOps and all these other kind of IAC practices with the technology that drives some of the most beautiful imagery in the entire industry, right? So the entire world looks up to visual effects as this incredible industry that can make the most beautiful images that's ever been seen, right? And then if you look at our infrastructure, sometimes we lag behind in that. So the question I actually asked myself was, let's talk about banking, right? This is a really weird transition, right? We go from talking about visual effects and making images to now we're talking about a bank, right? So this is the example, okay? You go to the gas station, and the first thing you do is you pay for some gas. What do? You tap your credit card, and it goes through and it fires off a transaction. Now, I think we all know that once you actually tap your credit card, the transaction gets approved and kicked back pretty quickly, right? I mean, it might take, 3 or 4 seconds, but I mean, considering that you're probably making that transaction along with millions of others at the exact same time, that's pretty impressive, right? I think we all know that sometimes we'll go log into certain tools that we have, and those could take, 30 seconds to load, and it's only got, 30 users on it, right? So how do we actually look at what they're doing and apply it to what we're doing in visual effects as far as infrastructure is concerned? And this is where I started doing a little bit of investigation. So a lot of, for example, banking industries, what happens is you fire off a transaction with your credit card. And then what happens is they typically have something like Kubernetes. Usually nowadays, they're all Kubernetes. It will decide, depending on peak hours, whether or not it needs to scale up or down based on the load of transactions that are being run at a point in time, right? So if we think about it, essentially your transaction fires off, Kubernetes picks it up, your container handles the transaction, and then if it's nighttime and they don't need that server anymore, they'll scale it back down. Now, something that was really eye-opening for me was that this process is entirely automated. there's actually nobody sitting there manually turning these servers on and off. It just kind of happens. It's kind of like when you go into your office and your lights turn off after you've been out, you leave for the night. You don't have to turn them off yourself. They turn off automatically. Or if you're driving your car and you pull up to a stoplight and your car turns off, and then when you go to hit the gas again, it automatically turns on, right? We're trying to save as much fuel as we possibly can. So these principles are actually really funny because we've been trying to solve this in visual effects for decades at this point, right? How do we only use the bare minimum resources that we actually need in order to do the job? So let's kind of like look at an example of if we converted this to visual effects, right? So instead of a gas station, we have an artist who's submitting a job from Nuke, and then that job submission hits the render farm. Sorry, not the render farm, the actual Kubernetes cluster. So the Kubernetes cluster is then going to see that there's now a render submission on the farm. And you can then go through and actually trigger the auto scaler to start providing render nodes for you. And then once the render is complete, it can then scale back down, and that is completely automated. Now, all we really have to do in order to leverage this is kind of just adapt a little bit of code to just swap out from a transaction to a render node, or even say a transaction to a workstation, right? So these are the kind of concepts that we were thinking about. Is this possible to go out and do this? Can we take these practices that these other industries have done? For example, banking, if they're only on one cloud provider, let's say, and that's all they have, if that cloud goes down, all of their transactions are going to fail and the economy is actually going to suffer. Much, much bigger issue than if we just happen to lose AWS or something like that, and we might be a little late on our delivery for our movie, right? So these industries also have solved multi-cloud. They've also solved failover. They've solved self-healing. They've done all of these problems already, and we just need to go out and learn from them. So this is what we mean by, in our eyes, modernizing visual effects, right? We're talking about an incredibly portable studio that can be launched to multiple clouds. We're talking about extreme cost-effective scaling because, visual effects, we do burst render and we do all these kinds of things to the cloud. But the other thing is that, like, if you talk about a bank, if they're burst rendering for, let's say, instead of, we're doing a delivery for a film, their version of a last minute delivery is essentially Black Friday, right? Amazon burst scales and does all of this scaling just to be able to handle the traffic that hits their website. Pretty similar to what we're doing when it comes to, we need to burst render to actually get a movie done, right? They're bursting and scaling everything they need. But they do it in a cost-effective manner that they can scale up and down, right? They're saving on their infrastructure, and all of that's automated. It's not like they have 50 people sitting there watching, turning the switches, right? It's all automated. And then on top of that, when you take these kind of concepts and you apply it, you find that you can actually have reduced render constraints, which means that I can render anywhere in the world on any cloud and even on-prem as well. And then on top of that, you can actually deploy not just the render nodes, but also workstations. And you can stand all of this up incredibly fast, right? So this is what we're talking about when we say modern visual effects. You'll see some tools over here on the right. We're going to talk about a few of them. We just kind of threw some logos up here. We use all of these tools to actually build our stack. But we're going to go ahead and talk a little bit more about what exactly is Juno, right? So the first thing I want to get out of the way is this isn't a sales pitch. Yes, we sell a product in the near future, but that's not what we're trying to sell you here. We're trying to talk to you about how we actually go out and do work using this stack, right? So definitely not a sales pitch. We're just sharing with you how we got to this place. So Juno is actually just a banner that we actually fly under. So Juno is actually two separate companies. There's Juno FX, which goes out and actually does visual effects work. And then there's Juno Innovations, which builds software, right? Now, when I initially founded the companies, what I wanted to make sure that Juno Innovations built what we thought was the answer to the future of visual effects. But at the same time, what I wanted to do was I want to make sure we actually used our own software and learned from it to make it the absolute best that it could be. So we have a primary product called Orion. It's already gotten out of alpha. That's a whole other thing. It went great. But we're not going to talk about that. What we're going to talk about today is how Juno FX actually goes out, builds its infrastructure, and deploys and runs its projects using all of these tools that we're going to talk about here in a little bit. So these are the common constraints that we found over the past few years, right? We're talking about after COVID and even before this, a lot of major large-scale studios have distributed teams across the world. They also, sometimes their infrastructure teams are pretty small. So we're talking about distributed teams around the world. We also have pretty small teams. And then on top of that, what we needed to do, especially for Juno, was that a lot of studios forget that you can scale up really fast. And we've all heard the horror stories of you use the cloud and then you get a massive bill at the end of the month because you forgot to turn something off. And that's because we usually forget we can turn on servers, but we almost never remember to shut them off. And when Juno first started, it was all attached to my credit card. So I made sure that when we started developing all these tools, especially when I was building the initial scalers and stuff like that, we needed to make sure that I could turn them off just as fast and aggressively as I could turn them on. The other thing is we wanted to look for some kind of platform that was able to support a VFX workflow. So that means that I can have a platform that can handle all of the scaling, I can handle all of this resiliency, but at the same time, I wanted to make sure that I could put a VFX workload on it. If I can't run these applications on it, it doesn't really make much sense to even go down this route. But we actually found some pretty awesome tools specifically for this. So this led to 4 concepts that we're going to talk about. Portability being one of the primary ones that makes what we're doing really, really special. This is what makes the actual studio be able to go out. And an example of this is about a month ago, we had a commercial come in that we were working on, and we ended up getting the commercial awarded to us. We actually spun up, but we had no footprint in Mumbai. We actually spun up an entire project and an entire cluster in AWS on Mumbai in about 15 minutes. 10 minutes after that, the cluster was deployed and actually ready for work. And then actually within the hour, our team was able to log in and start working out there. And then once we were done with the project, we made the delivery, we sunk everything back to our archives, and then the actual entire footprint was gone within a week. So that's the kind of extreme portability we're talking about. Now, something else was that this was actually an accident. Like I said early on, I was doing a lot of this on my free time. What I wanted to do too was I didn't want to commit to going to the cloud because the cloud was very, very expensive at the time. We didn't have a relationship with AWS like we do now. So what we needed to do was I went out and I bought 4 point of sale machines from McDonald's that you can get off Amazon for like $100. And then I also bought 4 Raspberry Pis. And that's actually on a rack that's behind me over in this other room over here. And Juno still to this day is built and tested on that small footprint of compute, right? We have a Kubernetes cluster that's spread across multiple architectures, both ARM and x86. And we actually test our workstations for CI/CD and everything in these little tiny micro environments. Each one of those machines only have 4 cores, and they only have 16 gigs of RAM. And a Raspberry Pi has 4 cores and 8 gigs of RAM, right? So Juno was actually built in its first early days to run on extraordinarily small hardware. And that's the kind of portability we're talking about. As far as resiliency, we wanted to find a tool that could go through and actually support itself. Like I mentioned at the beginning, we're only 4 developers that actually went through and built all of this stuff in the last 2 years. Well, coming up on 3 years now. And so we wanted to have a tool that would enable us to be able to use and protect the actual workloads while the studio was working. And we wanted to be able to focus on innovating instead of maintaining, right? Kubernetes does a ton of stuff with self-healing, the way that we have our infrastructure set up. We basically set a project, deploy it, and we don't think about it. It just kind of runs, right? And we go out and handle that, which is pretty great. Like I said, the scalability, we want to be able to burst up based on our traffic and burst back down if we need to. And like right now, we have 3 projects going on at Juno. We're only spending money right now because we don't have any artists working at the moment. We only have 1 EC2 running for the entire company, and it's actually only a T3 large. It's very, very small. And then we wanted the flexibility, right? So when we talk about flexibility, we found pretty early on that we not only wanted to support VFX, but the applications of what we've built has uses in both medical and also engineering, and that kind of industries have, you know, much larger budgets. And that means that we could start growing into other industries and start expanding our portfolio as the company grows, which is really where we started to say, this is where our studio can start thriving and going into other industries. And then also the thing that we're building would be able to eventually do that as well. So out of the gate, this flexibility provided to us by the platforms that we decided to use was just kind of there. Because if you look at Kubernetes and you look at where its use cases are, it's in an incredible number of industries and just kind of hands you all of this stuff for free, which is pretty great. So let's go through some of these concepts, right? So we've got portability. The usual suspects would be CloudFormation, Ansible, and Terraform, right? Everybody talks about these. They're great tools. They're awesome, right? There's going to be a whole talk about Terraform coming up soon. But I want to talk about why we didn't use it and why we actually tried all three of these tools. And I actually used Ansible at my day job a lot, and why Juno doesn't use these. So the pros are they're reproducible, which is fantastic. That is awesome. If you want to know how you keep your cloud bill under control, reproducibility and actually having kind of a chokehold on your cloud this is how you do it. These are the tools that do it. The other thing as well is you can actually wrap all of these in CI/CD, so you can do automated deployments. That helps with security. It helps with making sure you can check deployments. That's a great thing. The other thing as well is it's a declarative setup. So I want it to be like this. And if it's not like that, these tools will work it to get there, right? You're not automating a few steps. You're telling it where to go and it will find a way to get there. That is the difference. That's what makes these tools so powerful and awesome. Now, these are some downsides, right? This is where why these are actually the reasons why we didn't use these tools. So CloudFormation, Ansible, Terraform, there's really no abstraction, right? So when you're talking about specifically, let's talk about a Terraform configuration. If you build an AWS deployment, usually most studios start from even just defining a VPC in AWS all the way down to deploying an AMI and actually starting a service on the actual EC2. So you're talking about 100% of your studio is defined in Terraform. Everything is down to that point. So you're talking about even deploying one region with one project could be potentially hundreds, if not thousands, of individual resources and steps inside of a Terraform configuration. That's pretty difficult to get right. Much less now, if I need to do multi-cloud, I need to redo all of that work again and do it for GCP, right? So this is why when we started looking at Terraform and Ansible and CloudFormation, we were like, yeah, well, they're great, but they don't really provide the abstraction we're looking for. The thing that everybody's looking for is really, how do I make one configuration and it works across every single cloud? That's what we're looking for, right? Now, when we talk about that vendor lock-in, that's kind of what I'm talking about, right? You can't really do the abstraction. So you're pretty much locked in where, do I really want to dedicate a whole other set of resources and time and development time to maintain all of these different branches of my Terraform config to be able to support these different clouds? Not really. You don't really want to do that, especially if you're a small team of 4 developers like we are. That doesn't really work for us. And then on top of that, these are declarative, which means that for us, with the way that these configs usually work, is you say, this is what I need, but what if I don't need a certain resource? For example, I have a region in AWS and I have no projects there. I have nothing going on there. So why don't I just delete all of the resources associated with that region? That way I'm not wasting time and money, right? You can do that with Terraform, but it's pretty cumbersome in a lot of different ways. Now, that's not to say that people do it, and there are definitely tools wrapped around Terraform to handle this. Our opinions on this was actually before Terraform came out with their SDK, where you can start using things like Python and all these great tools to actually do all of the things I'm talking about now. So there's definitely arguments against what we're saying, but that's why we made these decisions. So what are the tools that we use, right, to solve portability? We obviously use Kubernetes. We've been talking about that. The best thing about Kubernetes is it abstracts away hardware. I don't care what kind of server you have. For example, if you have 4 Raspberry Pis and a point of sale machine with 2 gaming servers, it's just CPU, RAM, and GPU resources. That's all it is. And it presents it to you just like that. Encapsulated deployments. So that means that if I have, for example, a license server or something like that, this will go through and encapsulate and deploy it to that cluster. And that's exactly the same way it's going to deploy everywhere. A cloud native environment. Now, this is an interesting concept. When we talk about cloud native, we've been talking about AWS, we've been talking about GCP. Juno works in AWS because we have that relationship. But everything that we do at Juno as far as the studio side is completely deployable even on-prem. So we made sure that what cloud native really means is that you're taking a cloud native project like Kubernetes and it brings the benefits of the cloud, right? Hyperscalability, abstraction, all that kind of stuff down to you, right? You don't have to be in a cloud to be cloud native. Cloud native is just a way of working. That's kind of the new That's kind of a new concept to a lot of people in visual effects. So going cloud native means that you have extraordinarily like powerful flexibility. You can go to anywhere, which is great. And then on top of that, in Kubernetes, we can also do vendor specifics completely isolated in their own little corner of the cluster. So for example, if you're on AWS and I need to deploy, let's say, an ingress controller specifically for AWS to go through and create the NLBs and the load balancers, that's all isolated in an AWS section, and you don't even need to think about it. It's all automated and taken care of. And then on top of that, if I have a special GCP configuration, I can deploy that over there and it'll be encapsulated its own world, right? Now let's talk about Pulumi, right? Now Pulumi, it supports, this is the main selling point, is, by the way, when I learned about both these products, not products, but I learned about Kubernetes because of my previous job, but Pulumi I actually discovered on Reddit, on like our Kubernetes. They were just talking about it and I was like, oh, that looks cool. And I looked it up and I was like, wow, this is everything that I've ever wanted. Because when Juno first started, we were actually setting up Terraform. But then once we discovered Pulumi, we just threw all that away and went straight for Pulumi. Now, the idea was when we got Pulumi is it supports complex logic, right? So we're talking about, like I talked about before, if I am spinning up projects in a region and that comes with resources, support resources that we have to pay for example, transit gateways that are doing a global network that are interconnecting all of our licensed servers across many regions that allow our projects to be spun up anywhere in the world really, really fast. If I don't need a region, I don't want to pay for that transit gateway because it's expensive, or I don't want to pay for the license server and all that kind of stuff. I don't want to do that if there's nothing running. It doesn't make much sense. So when you inject something like Python, which is what we're using, right? We use Python. That's why I say Python based. Actually, Pulumi uses Node.js as the actual underlying runtime. But you can pick a bunch of different runtimes to define your configuration, which makes Pulumi awesome. But this is why we picked Pulumi, because we could go through and we could make this really cool set of logic to be able to define for our studio that I need to deploy in Mumbai. You add one block of code, 15 minutes later, I have everything I need. And then I can start deploying Kubernetes and start working. And then the best thing about Pulumi is that under the hood, it's really just Terraform, right? It's a wrapper around Terraform's open API, and it goes through and just generates the runtimes off of that. So anything that Terraform can do, Pulumi can do as well. So how did we achieve this? What does this actually look like when our studio goes out and does work? Now, remember when I talked about the story of we're going from Terraform deploying and we're going all the way through from the VPC all the way to finally I have an EC2 deploying a workload and I've got to manage that and set up all this kind of stuff. You might use Ansible or a mixture of both. That's not what we do, right? So what we do is our IAC, being Pulumi for us, we're not racing to get to a studio. That's not at all the intention. The intention is, where is our point of abstraction? Where is it that the cloud stops and our studio should begin? Now, that's an interesting thing to talk about, right? Is that if we look at what Kubernetes is the most powerful at, it's about abstracting and encapsulating your entire workload, right? So the beautiful thing is that what we've been going after for years in our industry is, how do I sit there and deploy to any cloud, anywhere that I want to go? And then I just want to put my studio there. I just want to put my studio there, right? So you need that point of abstraction. And that's where Pulumi and what we do is we do not target the entire deployment of our studio to be handled in IAC. All Pulumi is responsible for doing is getting to the Kubernetes cluster, which is only about 20% of our actual footprint in the cloud. And then everything else is Kubernetes. So that makes our resource count coming down from hundreds to potentially thousands of resources with all of these different servers and all this kind of stuff, to then all I'm trying to do is make a VPC with the security groups, maybe a license server, and maybe a VPN setup. And then I'm just trying to get to EKS, or I'm just trying to get to GKE, or I'm trying to get to AKS, right? That's all I'm trying to do, which means that I can now support multiple clouds with far, far less actual resources in the cloud, which is pretty cool, right? So we can go through and deploy as many resources as we want with Pulumi, do it across many clouds. And then on top of that, then we just let Kubernetes take over from there, right? Now, the really cool part about this is we're talking about the portability. So we've solved going across multiple clouds. How do we run on-prem, right? Well, funny enough, Kubernetes also solves this problem, right? So Kubernetes is just abstracting away hardware. It doesn't care if it's a VM in AWS or GKE. It doesn't care. And it doesn't care if it's, you know, a bunch of McDonald's machines in some guy's closet, right? We don't really care about that. Just get me to Kubernetes. And then once you're there, we're going to deploy our studio. And even locally, for example, when Des is talking about what he's doing, when he develops, we don't give him his own cluster on AWS and incur that cost. We actually deploy a micro cluster on your individual machine, and the entire studio deploys on one machine where you work locally and actually test the environment, which means that all three of these environment deployment specs are exactly the same, which is pretty cool, right? So this is what we're talking about with portability. So much less code that you need to maintain to support a bunch of different clouds. Your target deployment environment can be any one of these three locations. And now you have one singular code base, which is Kubernetes, where you're going through and defining what your studio in a box actually looks like. So let's talk about resiliency. So we actually follow a microservice architecture as well. We have fault tolerance. We also do horizontal scaling. So this is where, for example, Black Friday comes along and you need to scale up really fast. We use the same thing for if we all of a sudden have a ton of traffic, like a bunch of artists log in at the same time. We actually horizontally scale out and provision new servers automatically using Kubernetes. The exact same thing that drives scaling on, you know, Amazon.com is the exact same thing that drives us, and it's completely automated. This just comes for free. We didn't have to write anything to do this. Also, with Kubernetes set up and using microservice, all of our services are stateless for the most part. So if one of them goes down, they'll self-heal, right? Now, we have a Kubernetes backbone. We've talked about it a lot. The main reason being is that it has minimal intervention, has built-in scaling, awesome resource management, and something that's awesome is it also natively supports Spot instances. Now, the great thing about this is that most cloud providers know that you're going to use something like Spot. Now, Kubernetes, if you use its driver, it will automatically migrate your workloads from one instance to another, giving it basically a 3-minute window to say, let me shut down these services on this node and move it to the new one when I give you a new one. And then I'll pull the Spot instance out from underneath you. That's usually a pretty difficult thing to get right, especially if you're building this whole process yourself. This just comes for free with whatever cloud provider you're on, which is pretty awesome. Now, if you don't take anything else away from this presentation, this is the one thing that is probably the coolest piece of software that I have used in my entire career, which is Argo CD, right? So if we want to talk about what keeps extreme control over our clusters to make sure that a very small team like ourselves can take care of bigger studios and do these bigger workloads, it's Argo CD, right? So we'll go through and Argo reads a Git configuration and it enforces that on the cluster. Now, I think those of us that have worked in the cloud before, or if you haven't, as time goes on, configurations drift, and that's where costs start to rise. If you don't keep an eye on your cloud, you're going to start incurring costs you weren't actually aware of, right? So what do most studios do? They usually hire a team to go in and just keep an eye on it or something like that. What we do is we use Argo, which goes through and enforces and watches the cluster every few minutes and says, hey, has anything changed? Is it exactly the way it's supposed to be? If it's not, this will force it back to where it needs to be. And Argo CD is honestly the backbone of what helps Juno be as flexible and successful as it has been. And then we use Headlamp, which is for observability. It helps us do debugging. It's actually the thing that Des spends most of his time in, going in and debugging on clusters and stuff like that, which very rarely do we actually debug running clusters that are in production. It's usually we'll deploy, to the cloud sometimes a development cluster just so we can test GPUs and stuff like that in the cloud environment. And then he'll get into Headlamp to be able to access these GPUs and see how they're functioning and are configured. So as far as scalability, this is kind of what we've seen over the past few years working with larger studios that actually, scale with production. So most studios will go through and they'll say, I have a project that's starting on October 1st and it ends on October 7th. They don't know how much render they're actually going to need or how many workstations they're going to need. So usually they'll provision a bunch of nodes manually that say, I need 50, but they actually only use 30, right? They left 50 because they still don't know on October 2nd. They only need 25. All of a sudden, the next day, they need 55, so they provision up 75. And then you can see the stair stepping. And then the very last day, the project's winding down, and they have up to 100, and they just forget to turn it off. This happens all the time, right? This is all the time this is happening. And so we're talking about this much margin of slippage when it actually comes to what I actually need and what I have provisioned. So if we look at the math for this, this is 181 extra instances that we're paying for, which means that if we were to scale this properly, we could have saved about $1,700 if we were paying $10 a day, let's say, per instance. Like, let's just pretend, right? These aren't real numbers, but this is roughly the math that it comes out to, right? About $1,700 in this case. Obviously, GPU instances are a lot more expensive than this. But the reason why we saw that this was a problem was that because in a banking industry, let's make these numbers much larger, right? They're handling transactions on Black Friday. If for some reason all this was manual and then they forget the day after Black Friday to scale down and they have that much margin of excess, that is an incredible amount of money just thrown to the wind, right? And that's where Kubernetes and its autoscaler and all of this stuff that we're talking about really comes into play. So when we talk about flexibility, this is where we're actually using Kubernetes to do a lot of really cool things with actually deploying our pipeline, right? So we have an ephemeral pipeline approach. I think we all know that, like, we work at bigger studios and they usually, almost all of our pipelines get put on something like NFS or some kind of shared storage. Some other softwares like to go through and distribute their pipelines using something like pip or something like that. We do something kind of similar, but we don't do anything that's crazy, right? Python as a language has been around for a very long time, and they have solved a lot of the versioning problems, a lot of the packaging problems, and we have a tendency to kind of reinvent the wheel when it comes to that. So with what Juno does is we actually go through and distribute pre-populated pip caches that have all the versioning and all of the stuff that we need. We also follow standard CI/CD practices, and we treat our pipeline just as though we are distributing a Python package, which means that we can, instead of try to reinvent processes, we can just go look at how do other industries such as, like, banking or, Meta or these other industries that go out and do these things, how do they distribute their Python packages? And then we just do the exact same thing. Now, the cool thing about this is that when you distribute a pipeline to, for example, the actual network storage, every single time that you launch your pipeline, if you have 1,000 render nodes spool up, you're going to absolutely murder your storage to do this, right? So with the pip cache, what we do is all of it's pre-populated. We'll horizontally scale out based on all of those nodes joining, and then they'll grab their package, download the pipeline version that they need, run it, and then they'll start working, right? Now, the way that we actually load the pipelines is, I'll be honest with you, we just use UV. So we're obviously using the fastest, distribution method for Python that we can. And then we also have some other special sauce that solves a lot of the system dependencies as well. So we can do both of those two things as well. So solving Python and the system is pretty easy for us. Now, you'll also see in this graph that when the flexibility comes into play, we're talking about per project configuration. So every single project, I think we know that if you have a project management solution and they usually have one database and you have 50 projects going, it gets slower and slower and slower, right? So what we do is we actually go through and distribute. Every single project has its own database, its own deployment, its own project management for us. And then that means that our production, when the studio is actually functioning, if we need to continue to scale and handle that workload, Juno as a studio will not slow down because we have isolated deployments per project and everything is encapsulated, which makes it so that we can completely shut down whole projects without affecting others while still cannibalizing the exact same underlying server resources, which is pretty cool. And then we also have native namespace isolation. So we're talking about for something like TPN or security concerns, we can also do network policy isolation using CNI, which is container network interfaces. We can also go through and match that with our security groups, which encapsulate the actual Kubernetes deployment itself. So we can isolate projects. We can do an incredible amount of work when it comes to actually doing multiple projects on single resources, which is pretty cool. So we're almost done, but we're going to talk about some of the techniques that we do at the studio to actually go out and provision our infrastructure and go out and do work so quickly. So this is a Python library that we wrote it in Python so that we can go through and wrap a lot of the Pulumi stuff. So this is because Pulumi does support Python. We can do just normal things like make classes and make functions and make context managers and stuff like that. So for us, when I was talking about the global network, the transit gateways, all that kind of stuff, this is actually where intelligent network stacking comes in. So for us, if we actually have a network that we need to do, when we put everything in that context, it knows it needs to connect and interconnect all of these different resources together with a global network. So this includes shared license servers and all that kind of stuff as well. We also have multi-account deployments. So the really great thing about this is we have a sandbox account, a production account, and then we have another account. If I want to just randomly spin up a series of resources in another account for, let's say, bookkeeping purposes, I can actually just deploy it to another account by using a Juno account that we wrapped in the studio to be able to go and just target that as a deployment. And that's all going to be in the exact same network. Regional deployments. This is how we select a region. Pretty simple. You just say, I want to go to US East 1, and then I want it to have ECR, right? That ECR is the Elastic Container Registry, so we can deploy our images and get the studio up and running as fast as we can. And then this is where a lot of the magic happens. So all we're doing is we're standing up an actual Kubernetes cluster of some kind, right? Now, once this is actually deployed, everything I just described upstream, if this was our whole stack, we have a lot of other projects going right now, but if this is our whole stack, if there was no cluster, the global network, the Juno account, the Juno region, they wouldn't do anything because they're aware that there's no cluster being run in that region. So there's no reason to spin up those resources in this region, right? You can do these kinds of things in Terraform, but initially when we were using it, we decided that we were going to try to use Pulumi because we could wrap it in a programming language that could detect and figure out and make decisions based on what we actually wanted it to do, which this is the kind of behavior that we wanted. We only use what we actually need to do the job. And then this is where you actually kind of keep a chokehold on your cloud, right? We're talking about node groups, managed node groups that we use for AWS. And then we put guardrails on it so that the servers themselves don't outscale and cost us a ton of money. And we get a huge amount of bills coming in, right? So now that we have Pulumi that's already deployed our infrastructure, let's say, now this is where we do GitOps. Now, GitOps is a pretty awesome way of working. This is GitOps-driven deployments, and this is all using Argo. So we have a whole bunch of process that's going on with Helm, and we're doing deployments across different processes and different projects using this. But what we can do is that if you look at the bottom, it says production US East 1. That's the account that we're deploying to, and then the actual region that we're deploying to. And in each region, we actually have an array that gives us a list of projects. And this is what's actually going to be deployed to that Kubernetes cluster. So we have multiple projects per cluster. And then we actually, because Kubernetes natively supports this and we're using Helm, we actually can put a cluster to sleep. Or sorry, not a cluster, a project to sleep, which means that all of its data is in persistent volumes. We're pretty proud of the fact that all of our data is persistent in only, I think, 2 EBS blocks. And then once it's in its state, you can then just put the whole thing to sleep, which means we don't need any compute, which means servers will shut down and we can scale down even more. So like I said, we have, I think, 3 or 4 projects going right now. 3 of them are asleep because we already did our deliveries and we're just waiting to see if we can get confirmation that we can delete the whole thing. So we're literally only paying for block storage at this point, and all of the compute is not wasted, which is great. We have isolated deployments. So we pick the version of Orion we want to run, and then this is the branch. So we can do specific branch builds off of this, which this is also open source. If you're ever curious about how we do that, that's the way we do it. So yeah, and then this is what it actually looks like. So Juno as a studio has a regional controller that goes through and reads this file and then goes out and actually creates these applications using Argo, and Argo will then go through and create an apps of apps pattern, which means that it will read this, create separate isolated deployments in their own namespaces in Kubernetes for security reasons and to help us actually watch and see what resources are associated with which project. And that means that now technically the project's ready to go. It'll just start booting up. So the next thing that we want to talk about is how we do our containerized workstations. This is where a lot of people are really curious about how we do this. Everything in Juno is 100% containerized. There's not a single thing that we have that is not in a container. Now, I'll be honest with you, Des is probably going to answer some questions about this. But something that's really neat is that this is going to be, this is extraordinarily hard to do. This is very, very hard to do right. We spent a long time trying to get this right, and we're still working on it. But right now we have a workstation container that can run any DCC almost. And it's incredibly flexible, and we can deploy it to any scale, which is really awesome. So it's a higher upfront investment cost, but it's significantly more efficient on resources. So what does this actually look like, right? So this is an actual Kubernetes deployment. Let's say you have your underlying hardware, then the CRI, which is the container runtime interface provided by Kubernetes, is going to abstract away that hardware. And then what you do is you have the container itself, which has all of the system dependencies. It has its remote desktop protocol, and then it has its Juno FX environment, which is something that we're working on right now, where it actually encapsulates, based on the DCC, what system dependencies it additionally needs to function, which means that the container itself can be incredibly small, which is pretty great. And this is what ended up being kind of our special sauce. The workstations themselves being in a container made them incredibly powerful. We can deploy anywhere in the world very, very, very quickly. Now, this is what it looks like when we do cloud rendering for visual effects, right? So there's a lot of people at SIGGRAPH that are trying to figure out how to get this to work. We've been doing it for about 2.5 years, and it's awesome. We actually go through, we have an artist that submits a render. The render farm that we support right now is AWS Deadline. We do have plans to add more. And then we wrote something called a render operator that observes and mounts the actual render farm itself, and then tells the workstation operator, which is another operator we have, to request more nodes on demand whenever it needs it to go through and start scaling up to handle that render workload. Now, the benefit here is that when our render farm actually goes and does work, it's incredibly efficient and very, very, very fast when it needs to actually boot up and run if the nodes are already cached. Now, the cool thing here is that the workstation operator puts that workload on Kubernetes, and the Kubernetes autoscaler takes it from there. So this is what we're talking about. Think Black Friday, right? Bunch of transactions just came in, and now they see that they're all waiting in the queue. We're going to burst render as fast as we can and scale up using the autoscaler, and then we're going to get the nodes, and then the nodes will actually launch that exact same workstation container that we had running before, and it will handle the render workload and then shut down when it doesn't need, when it has nothing else on the queue to do anymore. So this ends up being where we save a ton of our money, right? So this is where we also slice these workstations. So we can get, for example, it might say 1 node per, but we might fit 3 render nodes onto a single server if we need to, right? We might 3 workstation nodes on a single node if we need to. So this is what actual workstation slicing looks like, specifically in Kubernetes. This comes for free, right? So just using Kubernetes, you get this. So once you have your workstation containerized, what we can do is we can actually see the CRI, which is a container runtime interface. We have hardware underneath it. So let's just say 16 CPU is there. What the workstation can do is we can issue a higher priority. So I think anybody here that's, been an artist and gone through and hates when you have a render node that sits there and takes up your resources, right? This is what is solving that problem for us, is because in this case, let's pretend that we're giving 8 CPUs to workstation number 1 on the left, and then we're going to give 4 CPUs and slice those into 2 more render nodes that are next to it, right? So what we're going to do is we're going to issue a limit to the 2 render nodes, and we're going to give them a lower priority. And then on top of that, we're going to issue a higher priority to the workstation and request more CPU. But the benefit here is we're going to put no limit on it. So if we're talking about usually virtual machines and stuff like that, usually when you launch a VM, you give it a certain number of CPU and its own kernel, right? Now, in this case, because we're in a container, they're sharing the same kernel, which means that we can scale resources and technically oversubscribe resources if we need to. And Kubernetes will detect that the actual workstation on the left needs more resources. So it will evict the render nodes off of your server immediately so that you don't lose your time. So if you, for example, go off to lunch and you leave your workstation running, which we do have an auto shutdown after 20 minutes, so don't worry about that. But what we will do is you're not using your machine, so we'll just put render nodes on there, and then while the renders are going, then if you come back and start working again, we'll kick them off your server. And this is all 100% automated. We don't touch any of this. And then this is the last slide that we have. This is probably one of the biggest ones. So this is actually leveraging modern GPUs. So for those of you who obviously, know AI and GPUs and all that kind of stuff, this is probably pretty interesting to you. It looks like I messed up some math though, because it says 8 CPU and I'm requesting 8. So I needed to put 12 CPU. Ignore that. So essentially what this is we have a workstation container with a higher priority. It has no limit. It's requesting 8 CPU and 1 GPU. And then we have the same workstation on the right, but it's a render node with 4 CPU and it's requesting a GPU as well. Now, in this use case, this is actually a single GPU. This is one GPU, and we are slicing it in half. Now, an interesting thing here is that we're not actually slicing the resources. They're just both two processes sharing the same GPU. So if you have, for example, a 2080 or a 4090 or an H100, whatever you're using, you can go through and actually still see that GPU and have access to what it needs, but the GPU looks at it as though you had Houdini open twice or Maya open twice. It's just a matter that we're going through and we're just have two workstations that show up as two processes on the GPU. So what does this actually look like, right? We have our hardware, we have one GPU, we have our NVIDIA container runtime, which needs to be installed on the host. We then have the CRI, which is the container runtime interface that interacts with the runtime. And then we have a dynamic GPU loader, right? This is for the driver loader. Now, the driver loader, which if you have questions about it, Des can answer this as well. We both have been working on this for a little bit. What you do is then it automatically loads based on your hardware. NVIDIA gives you the exact drivers that you need for this to function. So that also gets rid of a lot of the issues of getting the drivers to work inside of certain versions of Linux. So this is just issued to you, which is great. And then what you can do is you can configure saying, I want to take X amount of GPUs. And if they're this certain brand or this certain model GPU, I want to make sure I can slice that in 1, 2, 3, 4, 5, however many times you want. And those are called replications. And then what happens is that gets presented to the cluster. And then the workstations themselves can then request one GPU, which will then be taken off of the replication stack. And that's where we then start going through and slicing the GPUs, right? So we can technically run 4 workstations, 5 workstations, however, off of the exact same GPU. And yes, the number one question is going to be, well, do you oversubscribe it? Do you ever crash GPUs? All the time. We do it all the time. So the plan is that, well, not the plan, but the trick is to make sure that you balance your replication with the number of going through and like provisioning these workstations, right? So sorry, I just kind of like something popped up on my screen with Discord. Somebody's asking a question. Kind of threw off my train of thought real quick. But yes, so the trick is if you want to make sure you don't murder a GPU, which we have done many times, we actually tested with AWS. We have murdered huge EC2 instances by doing this. We actually had the replication set to like 12, and then we had 12 workstations hit it, and then the GPU just disappeared. Like it, I'm pretty sure that somewhere in their data center it blew up. But that's what we do. This is how this works. But yeah, so this is kind of the end of the presentation. Obviously, a lot of the stuff that we talked about definitely has a lot more to do with our infrastructure, not necessarily what Orion is doing. Like I said, this isn't a sales pitch, but Orion is the actual thing that drives a lot of the actual slicing and that kind of stuff as well. So if you're ever interested, you can go look it up. The company that does all this is Juno Innovations. That's me and Alex, and we've got 3 other developers. And yeah, this is kind of our setup. So thank you guys so much. And yeah, any questions?
Yeah, we have a few. Alex, thank you so much for that. It was pretty cool to see how that came about. Some of our questions are, do you think for a small shop, and maybe, when we say small, let's define that somewhere between, 5 to 20 people. Do you think something like this is a little bit overkill, introducing Kubernetes into your facility versus, maybe using something either off the shelf? I know that's where you're headed, but you originally weren't there, right? You're trying to create a product, but originally you were building this for yourself. So if somebody could go on that journey, is it overkill? Should they stick to something a little bit simpler? A lot of people are still using bare metal, just getting the VMs, that sort of thing, and maybe Docker and some containers. Do you need Kubernetes to manage that?
Yeah, I mean, so it was funny when I first started looking into Juno to do this, and it was funny, Des will probably mention some of this stuff as well. When we first started looking into Juno and trying to do this, we were doing the same thing. We were like, we're going to go see how much it costs to buy a whole bunch of racks and put them in the pool house over here in the corner somewhere, and then that's how we're going to get started. We're going to try to do it like everybody else does it. But then we started looking into it. We looked into Docker. We looked into all this kind of thing. I'm spending so much more time making sure that, like, the upfront investment of doing that. Yeah, you can turn on a server and get it running in 15 minutes, and you'll install what you need. But now you don't have any high availability. You don't have, that maintenance, all that kind of stuff. It's funny. the setup time for us for something like that, because we are a small studio, right?
Yeah.
We're very small. But we found that going this route, although it is difficult to initially get used to the concept, because this is so foreign to our industry. There's not many people doing this kind of stuff at smaller scales, right? But once you get your head wrapped around the concept, it's actually easier to do this than it is to actually do a lot of these other things, because then you get the benefits of the self-healing, you get the high availability, you get all of the lower maintenance. Like, we're a super small studio, and like I said, we deploy a project, I don't think about it. It just goes. Our artists don't need to think about it. It just runs, you know?
Did you start off like on the orchestration side first, more so than Kubernetes, or were you were like, I'm picking Kubernetes and I'm going to build everything around that? That's kind of my core.
Yeah, so it ended up being actually the workstation. So in about 2019, 2018, I saw that somebody ran no VNC inside of a container and they could run a desktop. And I was like, wow, that's really cool. I'm going to try that. And then I saw that I could, and I didn't know Docker at the time. And so I was like, well, I'm going to figure out what this Docker thing is. And then I started learning Docker, and then I started learning Linux. And then I already knew Linux a little bit. I didn't really know Linux until I run Arch, by the way. But the whole like doing that kind of stuff ended up being where we built the workstation first, and then it ended up being, well, how do I distribute this workstation? Because then I learned really quickly that if a container goes down and you launch with Docker Compose, or that server dies, right? If that server dies, it will not come back. You have to go and fix it, and that artist is done working. So you go right back to, how am I going to? I'm still on bare metal essentially. You treat it just like a bare metal server at that point.
Yep.
So yeah, I mean, that's kind of something where once we saw how we're going to maintain the cluster or maintain the studio, Kubernetes ended up being something where I was just on Reddit one day and I was scrolling, and I was like, I wonder, the studio I was working at was investigating Kubernetes. And I was like, I'm going to look into this some more. And then I started seeing all of these people doing home labs that have these like media servers that they're running, that like if they go down, their family will get pissed at them. So I was like, well, I'm going to start messing with this and see if it works. So it ended up being where Kubernetes just made a ton of sense. And the initial setup is a little difficult. I'll be honest. Setting up a Kubernetes cluster is far more involved than just launching a bare metal server. But like, if once you do it once, like we can spin up an entire, like my Raspberry Pis, I can do that in 15 minutes now. And it only took me a few days to learn how to do that. And once you do it, you can go anywhere. The power of this is incredible.
Do you think you can run any Windows-based DCC software in that image, or are you all just Linux right now?
I can say that yes, we have, but we're not supposed to. But we can. It's possible, but it's something where we're talking to Microsoft right now to figure out licensing. It is possible.
Technology pulled back, that's not the problem. It's more of just a licensing.
Oh no, yeah, that's funny. There's actually open source projects out there that can do completely legal Windows in a container with full desktops. You can do that, and it does actually work on our setup. The problem is the licensing is an issue. So that's where we can technically do it, but we don't have a clear path with Microsoft yet. So we're currently working on it, but it is possible. Actually, Des can probably answer some of that stuff.
Yes, we may have such a solution. Due to licensing, the way Microsoft license you Windows, it's not allowed yet.
Yeah.
But if you're running on Azure or you're bringing your own license, then I think it could work. There are no limits on Windows servers, as I read on the docs. I may be out of date, but this is the last info I had available.
How do you speaking of license servers, like how do you handle license servers in general? Dealing with, just looking at like your package there, you were showing like side effects and nuke, and obviously Blender is open source, so that's not a problem. But Maya and all that stuff, how do you typically handle that?
Yeah, so if I answer it from the studio's point of view, it's no different than almost everybody else, right? So you launch, that's the only VM. So I lied. We have one VM. Yeah, I forgot about that. We have one VM which has an RLM server on it, and that's interconnected with transit gateways across the entire network. So that global network thing
got access to basically all your endpoints.
Yeah, and then what we do, which is actually really cool, is in Kubernetes, you can go through and actually abstract away the license server endpoint. So we have the exact same external name service that goes out and hits the license servers. So that's what we do. That's the only VM that we run. So I think we all have the same Achilles heel, right? If that server goes down, everybody's screwed. Yeah, so that's the only thing that the studio has. Now, if we talk about more the product side of it, we are currently building relationships with a lot of these vendors to try to get to the point where it's all included. But that's really, really, really hard to do. That's very hard to do.
A lot of time spent dealing with that. I mean, I'm sure everybody here spends a lot of time wish they could get back.
Yes.
dealing with software vendors and licensing.
Yeah.
Looking back on this journey, what would you change now that you're 3 years in? You mentioned, that you went with Pulumi over Terraform and that sort of thing. Is there anything new, any other new tech out there, or something that you would go back, and you said you've taken about 3 years or so to kind of get to where you are.
Yeah, I mean, so this was all
web stacks change so quickly. Like these stacks change so fast. There's always some new framework out there,
Yeah, the one thing I'm really proud of, which, I mean, we have to be completely, transparent and honest, right? So like our company is very young. We're also very small, and we didn't bring any legacy with us, right? So it's not like we're a studio of like 30 years. It's bringing a pipeline that's 30 years old, right? That's really, really hard to go through and say, let's go ahead and update all this stuff to this brand new stack, right? That's honestly, that's really hard to do that. So we basically built everything ourselves from scratch. We had a blank slate so we could build exactly what we wanted. So that's we had kind of an unfair advantage when it came to that. But the one thing that I do think I'm really proud of is that we don't really have any real regrets or anything that we would change at this moment, because every time something comes out, we are pretty nimble. Like we'll change pretty quick if we need to. For example, Next.js came out with the apps router, and they changed from pages to apps. And that's, for us, our code base, because we're so small as developers, is our code base, we try to keep it as small and efficient as possible. So we actually made that transition over the course of like a week to get all of those benefits, to be able to do those transitions. So we don't really have anything that I would really want to change. We do use things like DevBox. We love DevBox. That's great. We love our CI/CD. We use GitHub for all of that as well. And then there's really not much. We did spend a long time on OpenLens, and then that kind of died. So now we got to Headlamp literally over the course of like a week, and then that's been a game changer for us. We've loved that. So yeah, I don't know. We don't really have anything quite yet. Maybe just more work, more money.
What speaking of that, you touched a little bit about this working on-prem, but you're cloud first, and I know you described what cloud first really means. Are there any downsides or limitations to going this route versus a traditional on-prem, set up your workstation deployment type of thing?
Yeah, so I mean,
costs still vary depending upon where you are and how long you're using it, and budgets, and all that fun stuff. So
yeah, I mean, so the thing that we try to do is that we definitely aren't cloud first. That's definitely, we're just cloud native. But initially, so now we're talking about more Juno innovations. And like I said, I'm not trying to do a pitch. I just want to talk about our
you have your own hardware on-prem.
Yeah. So the initial
clusters on there, and
so the initial business plan was for innovation specifically was we wanted to build Orion. And then we looked at previous attempts to do something similar to us, right? So that would be like Athera or like Nimble Studio. And we looked at what they were doing, and a lot of the stuff they were doing was really cool. But like, if you look at, Athera and you look at Nimble Studio, you had to drop everything you had and go to their solution. And so we looked at the bigger accounts. So we looked at, the huge studios, even like Zoic, right? You guys already have a pipeline. You guys already have all your hardware. You have all that stuff. There's no way you're going to drop your pipeline and go to that vendor. There's no way. You're never going to do that account because the lift and shift is too painful. There's never going to happen. So from day one, we picked Kubernetes because the assumption was that you could do BYOP. So we wanted to be able to say, okay, how is it that me being an infrastructure engineer, how could I have it where they could launch Orion on existing hardware, and how do we distribute it to them and make it so that it could mount their pipelines into our workstations and also mount their render solution and scale it out and then go that way, right? And so then the idea was that then we could get into those markets by getting those bigger accounts. That was the idea. But then what we did was we started looking at the actual we started looking at that how do we distribute it? I mean, we all know what, you can't just sit there and click a button to sit there and say like, oh, you know, next, here's your install wizard, right? That's never going to be a thing. And so it became a thing where Kubernetes just presented itself with all the cloud native benefits, where it encapsulates essentially a miniature cloud for yourself, right? A miniature cloud for yourself. So if I went to, for example, a studio and said, here, you can use your own pipeline, you can use your own render farm, you can use all your own stuff, deploy this next to your existing on your own hardware, deploy it there. You don't even need new hardware, deploy your own hardware. And then what you can do is you can mount your pipeline, you can mount your storage, mount your render farm, and then we can do it all in a cloud native way. And then you can scale it, do all this kind of stuff. And then when you need to burst to the cloud, you're not doing a huge lift and shift. You're just taking what you already have and just dropping it on the cloud, which is what we've actually executed. So we're not really cloud first. We just happen to be built in a cloud-like way, because the cloud-like way makes a lot of sense for these kind of deployments. But day one, Orion was never built to actually go immediately to the cloud. That was not the intention. Yeah.
A question that just came in that I was actually thinking about was, you know, you've gone all cube. You've mentioned that you have a relationship with AWS, and you know, going all cube is kind of, it's a little bit more agnostic. Do you think that there's any, you know, not going all in on, say, like AWS's cloud, you're missing out on certain tech stacks that they offer, certain frameworks that they offer that would simplify a lot of the stuff that you've built already?
Oh yeah. So this is actually the third time I've tried to build my own studio. This is by far the furthest we've ever gotten, right? This is we're actually doing work. The product's getting a lot of traction. I mean, we're doing a presentation with you guys. But the first time it was built 100% cloud side. It was 100% AWS services. So it was all using AWS Lambda. It was using API Gateway. We were using GraphQL and AppSync for everything. We were also using a bunch of different auto scaling groups and all that kind of stuff. And there are massive benefits to that. There are huge benefits to that. And there's a lot of cost savings actually with all that stuff. But when we looked at, like I said, those accounts that you're targeting, right? The bigger studios or these bigger accounts that you can get into, it ended up being where you run into the exact same problem. Those are huge benefits that you can get to like later on in the future, right? You can go and say, yeah, you know, you commit to AWS and you're good. But if you look at the banking industry and these other people that are out there, they're still using Kubernetes and they're still scaling out that way because it makes it abstract so they can jump between clouds, because they don't really care about the price of the cloud so much as they care about failover. So you want to have the same code running across AWS as you do as GCP, so you can fail over to their cloud in case AWS goes away. And so that means that even they can't use some of these managed services. Are there huge benefits to those applications? AWS Lambda is one of my favorite pieces of technology. Absolutely love it. Can't stand API Gateway, but I love AWS Lambda. I think it's great. But that's where a lot of that stuff is cool. But if you do that, that's definitely not a solution that you're going to be fully locked into AWS, which we love AWS. We still use them. We have a great relationship with them. But they also know, if you look at AWS as one of AWS's most successful products that they have in the visual effects industry, what is it? It's Deadline, right? Deadline runs on everything. It runs on prem, it runs in their cloud, it runs everywhere, right? So they're not opposed to doing portability to be able to do that, because still they'll get the license fee at the end of the day.
Yeah. What about synchronization of your databases between regions? We have a question regarding that. You know, how do you handle that while maintaining like a consolidated source of truth?
Yeah, so we do use Mongo. So we'll use usually the Mongo operator on Kubernetes to be able to do that. You can set up synchronization policies, but typically what we'll do is for at scale, the thing that we do that's pretty special is that our desktop protocol is extraordinarily efficient. So
yeah, what are you using for that, if you don't mind?
It's a secret sauce.
Secret. I know a lot of people are using all sorts of stuff. So Teradici.
No. No, it's so yeah, no, it's Chasm. We use Chasm.
Okay.
So yeah, we do so multi-monitor audio, but the nice thing about that is it's great because you have no need to download a piece of software to use it. So Teradici, you usually need a client, and it's easier to onboard because you're just using your browser, right? You get multiple monitors, you get really, really, really fast long range desktop. So for example, Des, he's out in Croatia, he logs in and works on our system in Virginia, and he gets a flat 30 to 60 FPS constantly. And it's a little bit of input lag here and there. But the thing is that it's perfectly usable. And we have artists that have logged in from Detroit over to Mumbai to actually do a comp to help with it. It's a little laggy here and there, but it's perfectly usable, which is way different than what you can say about like something like Teradici. Like you can't beat the speed of light for the input lag, but the presentation back is actually fantastic. So if you actually have your deployments be massive ranges for the desktop protocol, the synchronization between the databases isn't quite where we're not keeping multiple regions in sync all of the time. What we're really doing is we're just casting a really wide net and making it more usable so that we'll typically have more artists. So for example, if we have a region in Virginia, we'll have the entire continental United States and Canada completely covered by just Virginia. And we don't have to worry about synchronizing data all over the place. As far as actual data for, it looks like they're asking about the
for like the database, like
yeah.
you were mentioning, like say you were spinning up in 2 different regions.
Yeah.
You're gonna just have like your production management system in one location.
Yeah, that's usually just
are you somehow splitting those apart and it's synchronizing on the back end, which is,
No, we don't typically do that. We don't really need to. Yeah, we don't really need to. We've done tests with like Cloud Mongo and stuff like that, which will do the synchronization for us. But we found that like at our scale, and especially
you don't really need.
We don't need it. Like for example, the Mumbai project, we had a cluster in Virginia and we had a cluster out in Mumbai, and the project management was just handled by doing a forwarding to the Mumbai one, and it was perfectly fine. And because it's over the AWS backbone, even if we had 1,000 users, I mean, AWS handles that traffic in their sleep, right? So that's not going to slow us down at all.
Speaking of that, what about like any data synchronization between, like the nuts, the actual data footage and stuff like that, renders?
Yeah, so the way that we handle that is we're not that smart, right? So we only have 4 developers, and we probably could figure out some way to do that. But what we do is we focus on building relationships with other companies that are already doing global namespace. So you could talk about like Cumulo and stuff like that. We're currently talking to people like them. And so the cool thing is that Kubernetes gives us that power, right? Cumulo has a Kubernetes driver. So if you need to do data synchronization across multiple regions, you install your cluster in US East 1 and then also in Mumbai, and then you have a Kubernetes driver mount that cluster, and then it handles the synchronization through the global namespace, theoretically. They're doing read-write only right now, or sorry, they're only doing read only right now. Read-write might come soon. But that's kind of the idea, is that you would have an actual storage provider where that's all they do. That's what we would use, because we don't have the bandwidth to figure that out ourselves.
What about, you touched on it a little bit. What about managing costs? Have you guys created your own dashboards, or what, checks and balances do you have to manage cost, to alert you when you're kind of maybe going over a certain budget? Can you put in like an allocated budget or anything like that? Or
yeah, so
that's one of the things about just cloud in general. I think people have a hard time understanding, especially if you're a developer and you're given, AWS has just thrown you a whole bunch of credits and you're like, I'm just going to go do whatever I want. But from a production owner standpoint, like I have my thumb, always looking at costs and how they can get out of control with one quick render, that sort of thing. So.
Yeah, so that's the interesting thing is, right, the for us, we do enforce really, really strict node provisioning policies. So certain projects will have certain node budgets. So we'll go through and we'll monitor what's coming in, and we'll make sure that, like, okay, if you don't have enough budget for it and you can actually adjust that tap, we'll cut the node right out from underneath you. We won't let it go any further. We'll murder it right there. Which we've done that mainly because it's attached to my credit card most of the time. So I'm like, I don't make that much money. I'm not going to sit there and go bankrupt because somebody forgot to shut down a render, right?
Yeah.
So we'll do that and control that on our end, especially our studio side. It'll just sit there and just murder the whole node.
What about security? So
Yep.
obviously this is all in, your own kind of like VPL that you've created. Like the chasm, is that like from an artist perspective, that's the only entry point into your network, or
So
silo?
we have a pretty interesting way of doing that. We're currently talking to TPN about this. So the TPN side of things is kind of interesting, right? Their policies are great, and they're definitely, it's just pain to get through. But the interesting thing is that we have both high security and low security projects. So if it's a commercial and we don't want to worry about setting up a VPN up into our VPC, we'll go through and we'll just say, yeah, we'll hang it out, and we have MFA, we have a whole bunch of authorization that goes through that so that the endpoint can be hit securely. And we'll go through, and TPN seems to be okay with that. Like they've looked at it for not for high security, but if we're talking to them about like, yeah, this should be low security, this should be fine, that should be okay, right? The biggest thing there is that if we look at how we deploy Orion, right? Orion is no different than if you were to deploy like ShotGrid, FTrack, or Aeon, right? You just deploy it as a service. And so it's on you to protect it, essentially. If it's on your own hardware, if you have a high security project, we do not enforce the security on it if you're deploying it yourself. So what I mean by that is like if you have a VPN set up and you're deploying it on-prem or whatever, we're not going to sit there and require that you hang an endpoint out just so that you can access it, right? It's same VPN, you hit it, it's just a web service, right? It's just a web service that's being hit. So that's kind of how we do it for our high security is we have separate VPCs that have locked off access. You VPN up into it. Another piece of probably our second favorite piece of software is Twingate. So we do zero trust Twingate going into the actual endpoints. We have roles and permissions to only specific ports and specific hosts, so we can control access into Orion at that point. But Orion itself, it's entirely on how you configure it. You can do any kind of auth provider, you can do any authentication. We don't really care, but it's entirely on how you configure it. A low security project, like I said, we'll just hang the endpoint out for our artists to log in so they don't have to do anything. If they need a high security access, we'll give them a Twingate login, and then they have to jump into a VPC for us.
Gotcha. Through chasm.
Yeah, well, yeah, I mean the containers themselves, it really depends. It can be, we're currently working on adding other desktop protocols in the future. So like eventually you will be able to do something like Teradici or No Machine if you want to. But we have to build a relationship with those guys. So if you know anybody, let me know. So.
Yeah. I think you kind of answered this before, but have you tried deploying to a hybrid environment, half on-prem, half hyperscaler? Maybe just revisit that a little bit.
Yeah, so I can tell you we have deployed a stretch cluster from 4 Raspberry Pis up to an EC2 instance. We have done that. It does not work well. So typically what we do is the problem there has nothing to do with the actual compute. The problem is the storage. The storage is the issue. So you can make a stretch cluster, no problem. You lose the benefits of something like a managed Kubernetes service. If you are a startup and you watch this presentation, you're like, hey man, that looks really cool, I want to give it a shot. Do everything you possibly can. And this is my one piece of advice. If you want to do what we're doing, do not read any articles about deploying Kubernetes manually on a cloud. Do not do that. Go use EKS, use GKE. And then if you want to pass through TPN, as far as like, for example, security vulnerabilities, all that kind of stuff, what you want to do is you also want to use something called a managed node group, because then what happens is, and this is just a little bit of advice, for security, especially Kubernetes, is that a managed node group is where the actual EKS cluster nodes are managed by AWS and they get regular security updates. So when you get that question on TPN saying like, hey, how do you keep your systems up to date? You just point at Amazon and say, go talk to them about it. And that's what you do. So managed Kubernetes service, because you get all of the benefits. It is a little bit more expensive, but they do all the provisioning for you. They do all the setup for you. And then also, if you can, usually all these cloud providers have some kind of way of where they provide and manage the nodes for you and all of their security updates. So you don't have to do anything, which is great.
If you're a lead developer or maybe, a lead pipeline or head of pipeline, how would you go about pitching something like this to management and saying, hey, this is where things are headed. This is where I think this is, going to save us a lot of money. How would you go about doing that? Like what KPIs and things like that?
So I might not be the right person to ask because like so just full transparency, I've been working in a lot of different studios, and for the past, 10 years, I've been trying to do something like this. And so I had to leave and go do it myself. So I might not be the right person to ask. So I guess the better question is, Saker, what would I have to tell you to make you make that decision?
To convince me?
Yeah, that's probably the better question, right?
That's a good question. I think this is only solving one part of the puzzle. You touched on it there with there's rendering, there's depending upon the size of your company, how large you are, how much of an investment on-prem equipment that you have, whether it's on-prem or at a colo. There's just, it could go on and on, existing cloud provider contract, all that stuff, right? So keeping things nimble. I think the real thing is testing. So I think I can speak for probably anybody, right? Watching this presentation, you get really excited about it. It looks really cool. I think bringing, whether, if you have the resources to have put some hours aside for your team, I think that's key. One of the questions that I didn't get to ask is, what, for a developer who is what I'll call a traditional developer, where should they be learning? What should they be learning? What should they be doing to maybe pivot? Because, taking advantage of web stacks, this is the future, right? Most of the pipeline tools that we're developing now at Zoic are all going web-based. We're moving away from PyQt and things like that. It's got to be more web accessible and that sort of thing. And everything's behind a key cloak server, that sort of thing. So I'm curious, what your perspective is coming from all these different VFX houses and your background.
Yeah, I mean, this is something where it's really funny. So everything you're describing, we're actually moving towards. So we have a PyQt pipeline. We have a really, really fast one, and it's really simple, which is great. A lot of these other pipelines, they can get really complex with 1,000 different steps, which usually they're supporting CG. Right now, we're strictly 2D, but we're moving into CG. It's not because we're technically limited by it. All of our workstations can do it. It's a matter of we just haven't had the time to go and build that pipeline. So we have been looking at some off-the-shelf solutions like, Aeon or ShotGrid or F-Track. But it's kind of fun because we build everything ourselves, that a lot of the thing is like, might just do it ourselves. We'll see how it goes, and we're starting to grow this year, which is really cool. But I mean, yeah, I completely agree with you. The vision that we have is that we are doing a lot of WebSocket, fancy stuff like that. We would love to be able to have our dashboard where you don't have to touch anything. Nuke opens up as just Nuke, and everything is a WebSocket server that you communicate with. You can sit there and create whatever tools you want. And then when you do a publish, you do it in the web UI, which I didn't show anything or demo what the workstations actually look like. But they're all encapsulated, and you could just sit there and have a button that slides down and clicks a button that says, hey, create my publish or create my render, do whatever, submit to the farm. And my long-term goal, let's say in a year, is or 2 years, is we want to have 0 QT, none of that, because the fat of QT is huge. And so our workstations, on average, like an entire workstation that can do all this stuff can go anywhere from 1 gig up to like 2 gigs in size, which is a container, right? But if you think about that, that's an entire application in and of itself, right? A whole desktop environment. So
cool. This might be for another topic, but CI/CD, you touched on it a little bit. You're using GitHub?
Yeah, we use GitHub Actions. Our journey started with GitLab, locally hosted. Then we went to Git, and then we went from there to then we were like, yeah, we just absolutely love GitHub. It's been awesome. We love GitHub Actions. The chaining and all the stuff that you can do with it is awesome. Super flexible.
Any of the security stuff that you're taking advantage of that, like checking your code for vulnerability and
we use Dependabot. We use all that kind of stuff as well. We also do regular. Yeah, we use Trivy. We do all that kind of stuff as well. So when we build our containers, we also dump a report of the vulnerabilities, and we'll have automated checks as well, because for us, we wanted to make sure when we're talking to TPN like we are now, they want to make sure you're doing all that stuff. So it's really easy for us to dump that. So
yeah, I'm always curious because in the past, especially in VFX studios, security is kind of an afterthought, and that's just every industry, right? And I think changing that mindset and taking security head on while you're writing the code is much better approach. Being proactive about it.
Yeah, I mean, something that we do that I'm actually really proud of is we did focus on security kind of first and foremost because we knew that it was going to be such a problem to get through TPN if we didn't do it first off.
Yeah.
So our CI/CD and all that stuff is set up for that. And something that I'm actually extraordinarily proud of is that our CI/CD can all run entirely locally with our individual people that are developing. So we can run like make test, and they're all make targets. Make test runs the exact same thing on the CI/CD it does locally. All of our linting, formatting, all of our dependencies, and including even scanning, all of that can happen locally. So our artists, or not our artists, I keep saying artists, our developers can handle all of that stuff as well. So we're very, very, very portable, but it's all built in from the start.
Awesome. Well, I think that's going to wrap things up. A big thank you for this presentation. I think it was great. People are going to look back on it, I'm sure, once it comes out in a few weeks. And if any questions come up, please feel free to reach out to the Pipeline conference, and we will hopefully be able to get those onto Alex and answer those for you guys. Just a reminder, Thursday at 1 p.m. We'll have our next topic. So we'll be getting a little bit more into Terraform with Netflix, and Effectual. So thank you.
Great.
Appreciate it.